Question: how does an electric generator work? Here I have a loop of wire in between two bar magnets, and the loop on the left and on the right is going into and out of the page. It's not diagonal up. It's into and out of the page. I'm just trying to draw a three-dimensional diagram on a two-dimensional plane here. So here I'm adding an axle, and this axle is going to be attached to the loop. And if I crank this axle, I'm going to physically move that loop so that the wire on the right goes up and the wire on the left goes down. And what happens when you physically move these wires in the magnetic field, the charges on the inside of the wires go along for the ride. And we know that moving charges experience a magnetic force. So a new induced current gets created inside this loop of wire when the handle gets cranked. Now, in order to be able to keep cranking it, we have to attach the two ends of the loop to commutators. Now, we're not going to use split ring commutators this time. We're going to use solid commutators. And one wire is soldered to the first one, and the other one then goes down the middle and is soldered to the second one. And then there's two different metallic brushes that are connected to the commutators. So now when I crank that handle, the current ends up going one way during the first half of the turn. And then as soon as the strand on the left side flips over to the right side, the current's going to change direction. So as I'm cranking that handle, the current changes direction every half turn. And thus an alternating current gets produced. Now, instead of having a person cranking the handle, you can hook up a fan to that axle, and then you could have like wind turn the windmill, and when that turns the fan blades, that ends up flipping the loop, moving the wires, and generating electricity. Or you could put that fan in water, and when water goes over Niagara Falls, it turns that fan and it changes, moves that magnetic loop. Now, the special name for this fan is a turbine. And a lot of times what is done to move the fan is water is heated and turned into steam, and steam is blown against the fan. And one way the water is heated is by burning something underneath it. Here on Long Island, natural gas is burnt to heat the water, to turn it into steam, to blow the steam against the fan, to turn the loops of wire. Now, normally there's more than one loop. There's many loops so that overall more electricity can be generated. Ready?
Yeah.
Here I have a simple generator, and you can see the horseshoe magnets. And in the horseshoe magnets, there's a coil of wire. And I'm just going to take this handle here, and I'm going to physically flip the wire, the loop. And by me physically moving that wire, the charges in that wire are going to experience a magnetic force down the axis of the wire, and they're going to get pushed. And this is going to induce a current and light up this light bulb here. Just by physically moving a wire in a magnetic field, I can generate electricity. And the electricity in this light bulb is going this way and then stopping and then going this way and then stopping and then going this way and then stopping and going this way. It keeps changing direction every half turn. Thus, I'm producing alternating current. In a future demonstration, I'm going to prove it to you that it's alternating current. Okay.